we are given a question here which is a linear programming question. So it says max z is equal to 4x1 plus 3x2 subject to 2x1 plus x2 less than or equal to 40. Equation 2 is 2x1 plus 2x2 less than or equal to 60, where x1 and x2 are greater than or equal to 0. So we have to, according to the question, that we have to apply the graphical method. So let us answer the question. First, what we do is we change the two equations into equality sign. The sign here, the inequality has to be changed into equality sign. Now, equation 1, we have, say, let's say solution here. In equation 1, we have to change it to 2x1 plus x2 is equal to 40. Now we have to say if x1 is equal to 0, that is, we have to find the coordinates. x1, x2, let's put it here. If x1 is equal to 0, what would be x2 in this case? If x1 is equal to 0, x2 will become 40, right? And if x2 is equal to 0, what is x1? If x2 is equal to 0, what is x1? x1 will become 20. Okay? That is for equation 1. For equation 2, we have 2x1 plus 2x2. We have to make the same arrangement. Okay. Now, if this is equal to 60, okay? If x1 is equal to 0, what will be x2? x2 will become 30. Okay? If if x2 is equal to 0, x2 will become what? So if x2 is equal to 0, x1 will become 30 also. So let us draw a graph here now. So we'll have this graph. We are not drawing it to scale actually because the measurement, we can see here, it will be longer. This is 0 point where the z is 0. In this case, our z is 0 here. Now, for equation 1, we have, let's say here, from here, say 10, okay, 10, 20, 30, 40, and let's say 50 here. And this side, we have 10, we have 20, we have 30, we have 40. Now for equation 1, we have 2x1 plus x2 is equal to 40. That means when x is equal to 0, when x1 is equal to 0, we have x2 is equal to, this is x1, x2 is here. When x1 is equal to 0, x2 is equal to 40. That is here. And when x2 is equal to 0, x1 is equal to 20. That's here. So we connect this line. Okay, this is equation 2x1 plus x2 is equal to 40. For equation 2, we have 2x1 plus 2x2 is equal to 60. When x1 is equal to 0, x2 is equal to 30. When x1 is equal to 0, x2 is equal to 30 here. And when x2 is equal to 0, x1 is equal to 30. Plus all here. We connect the lines. Okay. Now you can see that this is equation 2. 2x1 plus 2x2 is equal to 60. The next thing is we have to see what will be the value of x1 and x2. The values of x1 and x2 will be here in this area, this region here. It will never be outside this. So this is where the optimum solution is found, or what we call the feasible. This is the feasible region. This is the feasible region where the optimal solution is found. It can never be outside. Now, how do we find the values here again? Since we have 2x1, is that? The first equation is 2x1 plus x2 is equal to 40, and the second equation is 2x1 plus 2x2 is equal to 60. Now we have to use our determinant or Cramer's rule. Here we say, what is x1? x1 is equal to 60, that is 40 times 2, right? Minus 60 times 1 divided by 2 times 2 minus 2 times 1. So x1 is equal to 80 minus 60 divided by 4 minus 2, which is equal to 20 divided by 2, which is equal to 10. That is x1. So we can know x2 from either equation 1 or equation 2. Now, you can put x1 is equal to 10 in either equation 1 or equation 2. Then we say take equation 1. 2x1, now we know x1 already. 2 times 10 plus x2 is equal to 40. Therefore, x2 is equal to, this is 20. 20 plus minus, you subtract it from 40, you get what? 20. Now you know x1 is equal to 10 and x2 is equal to 20. Substitute this into the objective function. The objective function here before was z is equal to 4x1 plus 3x2. That was our objective function. So we substituted here to get the maximum profit. So 4 times 10 plus 3 times 20. 4 times 10 is 40 plus 3 times 20 we get 60, and this is equal to 100. So now the maximum profit is 100. It can be in SSP or it can be in US dollars. If you have enjoyed the lecture, please comment, like, and share. Thank you for watching.